So the given question says, if the focus of the parabola, they have given the equation of the parabola. The equation is y minus beta whole square is equal to 4 times x minus alpha. So the focus of this particular parabola always lies between the lines x plus y is equal to 1 and x plus y is equal to 3. Then in the option parts, they have given the set of range of values of alpha plus beta. In different options, they are given us with the different set of values. We have to identify the correct option. Okay, moving to the solution part, let me write the equation of the parabola very first for you. So we have the equation as y minus beta whole square is equal to 4 times x minus alpha. Okay, also they are saying that the focus of this parabola lies between two particular lines. For some time I am naming this line as L1 and I'm naming this line as L2. Now if I try to plot these lines in two-dimensional plane, this is how the figure looks like. Okay, so again this is our line L1 and this is our line L2. Now just let us now have a very close look on the equation of the parabola. The equation says, I'm writing this equation once again. So the equation says y minus beta whole square is equal to 4 times x minus alpha, right? Okay, one thing which is very clear is this is not the parabola, this is not our standard parabola which has its vertex at the origin. Okay, so definitely this is a parabola which has its vertex at some coordinate at some other point other than origin. How we are going to determine the vertex, how we are going to determine the focus? We are going to use the concept of shifting of origin. Okay, so say for some time let the origin has been shifted to some new coordinates, and with respect to that new origin I am assuming the equation of parabola as y square is equal to 4 into a into x. A I am assuming as 1 because here again if you see 4 times this can be written as 1 into x minus alpha. So 4 into 1 into capital X, right? What is capital Y and capital X? These are the general variable coordinates with respect to new origin, correct? Now if we compare both of these equation, one thing which is very clear is we have the value of y, capital Y as y minus beta, and the value of capital X as x minus alpha, correct? Moving further, with respect to the new origin, what are the coordinates of the vertex? The coordinates are y is equal to 0 and x is equal to 0. What is this? These are the coordinates of the vertex with respect to new origin. That means if in place of capital Y I place y minus beta, so y minus beta becomes equal to 0. From there I'll get y is equal to beta, and also in place of capital X if I place x minus alpha, from there I'm going to get x as alpha, right? That means these are the coordinates of the vertex with respect to the old origin or with respect to the original origin. Okay, so we have the coordinates of vertex as alpha comma beta. I'm writing this once again for you. We have the coordinates of vertex as alpha comma beta. What comes next? We have to determine the coordinates of the focus as well, because that was what actually question is based upon. They have clearly mentioned that the focus of this parabola lies between the lines L1 and L2. Now if you have a look at this equation, the value of A is 1. What is A? A is the distance between the focus and the vertex. Obviously this is the case of a horizontal parabola. Okay, so that means at 1 unit right to the left of vertex, sorry, I'll repeat myself again, that means at 1 unit to the right of vertex focus is going to lie. Okay, now since this is the case of a horizontal parabola, tell me the value of the coordinate which lies 1 unit to the right of alpha comma beta. Obviously the coordinates of focus are going to be alpha plus 1 comma beta. You have to travel 1 unit right to the left of, sorry, you have to travel 1 unit to the right of alpha comma beta. You won't be changing your y coordinate, you are changing your x coordinate only, and the x coordinate will become alpha plus 1, whereas the y coordinate will remain beta only. Is it clear? So we have the coordinates of focus. Now, according to the question, this particular point, the coordinate of focus should lie between these two lines. So for some time, I'm assuming that this is our focus. Randomly, I'm putting some point on the two-dimensional plane, and we know that the coordinate of this point S is alpha plus 1 comma beta. Right? Now, if you consider line L1, origin and the point S lies on the opposite side of this line L1. Right? So that means if in the equation of line L1 I put origin, this is not 10, this is L1. Let me write it again for you. If in the equation of line L1 I put origin and then multiply the same thing by putting the point on the equation of the line L1 by putting the point S. So this value has to be less than 0 because origin and the point S are lying on the opposite sides of the line. Okay, so what is L1? Can you tell me? Yes, this is what the L1 is. L1 is nothing but x plus y minus 1 is equal to 0. What is L2? L2 is x plus y minus 3 is equal to 0. It is already mentioned. Just have a look on the figure. So in the equation of line 1, I am putting 0 comma 0 in place of x and y. Okay, what I'll get? I'll get 0 plus 0 minus 1. This is getting multiplied by, now in the equation of the same line, I am putting the coordinates of s. So in place of x, I'll be putting alpha plus 1. In place of y, I'll be putting beta. What I'll get? I'll get alpha plus 1, not beta, alpha plus 1. Then in place of y, I'll have to put beta minus 1 is less than 0. Now, have a look at the equation of line L2. If you see line L2, focus, which is the point S, and the origin lies on the same side of this line. That means in the equation of line L2, not L1, in the equation of line L2, if I put the coordinates of origin and then multiply it by putting the coordinates of the focus, it is going to be greater than 0. Why? Because both these points lies on the same side of the line, right? So that means in the equation of line 2, I have to put origin, the coordinates of the origin. So it will become 0 plus 0 minus 3 multiplied by, now in the same equation, I have to put the coordinates of the focus. So it will become alpha plus 1 plus beta minus 3 greater than 0. These are the two sets of inequality which we have got by applying the condition, right? Okay, so moving forward, this is what when we have taken the case of line L1, and this is what we have got when we have taken the case of the line L2, right? Okay, now I'm going to simplify this very first. So in the first bracket, we just have minus 1 is nothing but minus, and in the second bracket, plus 1 and minus 1 will get cancelled out. So I'll get alpha plus beta less than 0. If I multiply both the sides of the inequality by minus 1, the inequality will reverse its sign. What I'll get is alpha plus beta greater than 0. Now if I consider the second inequality which we got by considering the case of line L2, the first bracket reduces to minus 3 and the second bracket becomes alpha plus beta minus 2 greater than 0. Now if I divide both the sides by minus 3, inequality will get reversed. I'll get alpha plus beta minus 2 less than 0, or finally I'll have alpha plus beta less than 2. So see, from here I am getting that 0 is less than alpha plus beta, and from here I'm getting that alpha plus beta is less than 2. So this is what the final range of alpha plus beta is going to be, right? So alpha plus beta is going to be greater than 0, but on the other side it is going to be less than 2. Okay, now let us have a look at the options part. Yes, option C is the absolutely correct option. So in this question, we have to find the mirror image of the directrix of the parabola. The equation of the parabola is given to us as y square is equal to 4 times x plus 1. In the line mirror, x plus 2y is equal to 3. So we are given with the equation of a parabola. From there, we can conveniently find the equation of the directrix, right? Now, what is the mirror image of that directrix with respect to this line? Or we have to determine the equation of the mirror image of the directrix with respect to this given line. Okay, before moving forward, let us have a look at the options also. So these are the options written in front of you. Okay, now let us jump to the solution part. Again, I have written all the set of information which was required in the solution part. So yes, we have the equation of the parabola, and yes, we have the equation of the line mirror. Okay, first of all, what we are going to do, we are going to determine the equation of the directrix. Okay, how we are going to determine? So if you have a look at this equation, this is not the equation of a standard parabola. This is the equation of a parabola whose vertex is shifted to some new coordinate. Or we can take it in this way, that the origin has been shifted to some new coordinate. Now, if I compare it with the equation y square is equal to 4 times a can be assumed as 1 into capital X. From here, I am getting as the value of capital Y as y and the value of capital X as x plus 1. This is what? This is the equation of the parabola with respect to a new origin. Okay. Now with respect to the new origin, the vertex of this parabola with respect to the new origin, the vertex of this parabola is going to be y is equal to 0 and x is equal to 0. From here, if in place of capital Y I place a small y, I'll get the small value of a small y also as 0. And in place of capital X, if I place a small x plus 1, I'll get the value of a small x as minus 1. Minus 1. Right? So this is what the vertex of the parabola is going to be at. The vertex is going to be at minus 1 comma 0. See, the value of x you are getting as minus 1 and the value of y you are getting as 0. Okay, now I'm going to draw the figure. Okay, so this is my two-dimensional plane. I know that the vertex of this parabola is at minus 1 comma 0. This is my point where the vertex is going to lie. And if you have a look at the equation says capital Y square is equal to 4 into 1 into capital X. That means it's a case of a horizontal parabola opening towards the positive direction of x-axis. So this is how our parabola is going to be, right? This is the coordinate of the vertex, say V, and the coordinate is minus 1 comma 0. Cool. Okay, now comes how to find the equation of the directrix. So the equation of directrix of this parabola is x is equal to minus a, which is minus 1. In place of x, if again I'll put x plus 1 is equal to minus 1, from here I'll get x is equal to minus 2. So that means somewhat from here the equation, the directrix is going to pass, and the equation of this directrix is nothing but x is equal to minus 2. Cool. You can also find the focus of this parabola. The focus is going to lie 1 unit to the right of vertex, so the focus is going to lie at origin, but it is of no use here. Okay, what comes next? Next, let me draw the line mirror for you. Okay, so the equation of the line mirror is x plus 2y is equal to 3. Now if I put the value of x as 0 here, I'll get y is equal to 3 by 2. And if I put the value of y as 0 here, I'll get x is equal to 3. That means the x intercept is 3 and the y-intercept is 2. So the line is somewhat going to be like this. This is what the line mirror is going to be. Okay, what is the equation of this line? The equation of this line is x plus 2y is equal to 3. Now we have to find the mirror image of the directrix with respect to this line. Mirror image of this directrix. Okay, let me change the ink color first. So I'm assuming that this is what the mirror image of directrix going to be. Okay, I'm naming this point as say P. Okay, let me name every point. So I'm naming this point as A. I'm naming this point as B. This point is already V. I'm naming this point as C. Is it clear? Okay. Now I think the figure is pretty clear to you, right? Okay. And I am naming this line as L of mirror. Now I'm naming this line of L O. I'm assuming this line as an object, and I'm assuming this line as an image. So L of I. Okay. Finally, we have to determine the equation of Li. Right. Now I'm going to remove these set of information which we did just for the sake of determining the vertex, the focus, the equation of directrix of the parabola given to us. Okay. Now what I'm going to do next, I'm going to apply a very easy concept of physics which you have already studied in your class 9th or probably in class 10th. So you have already studied that when an incident ray hits on a mirror, it gets reflected, making an equal angle with the normal. So the angle of incidence is basically equal to the angle of reflection. Yes, I is equal to R. So that means if my directrix is acting as an incident ray, and if I'm assuming this angle as theta, angle CPA, just have a look at the figure because the figure is not drawn that neatly. I'm not that good in drawing. So angle CPA is theta. That means this angle is also going to be theta. Angle APB is also going to be theta. Why? Because in the mid there is a mirror. Directrix is acting as an incident ray and Li is acting as a reflected ray. Right? Okay. What I'm going to do next? So one thing which is very clear is that we can determine the coordinate of the point P. The x coordinate of P is going to be -2, right? Why? Because it is standing, it is on the line x is equal to -2. So x coordinate is always going to be -2. Doesn't matter any way you travel vertically on this line, right? How I am going to determine the y coordinate? If you clearly have a look, the point P lies on the mirror line. So the moment I'll put x is equal to -2 here, what I'll get? I'll get -2 plus 2y is equal to 3. That gives me 2y is equal to 5 and I'll get y is equal to 5 by 2. That means the y coordinate of this point P is going to be 5 by 2. Cool? I need space to explain you this question on the same slide. That's why I'm removing each and everything. Okay. So we have determined the coordinates of the point P. What I'm going to do next? So we know that angle CPA is theta and angle APB is also theta. We know that angle PCA is 90. So that means angle PAC is going to be 90 minus theta. Right? Have a look at the triangle APC. Clear? Can you tell me what is the value of angle PAB? So angle PAB is going to be 180 minus 90 minus theta. What it will become? It will become 90 plus theta. Clear? You add both the angles, you will get 180 degree. So angle PAB is 90 plus theta. And if you have a very careful look at the angle PAB, this is what the inclination of the mirror line is with respect to the x-axis. Yes, so that means tan of 90 plus theta will give me the slope of the mirror line, right? And we already know the slope of the mirror line. What is the slope? Minus coefficient of x upon coefficient of y. That means minus 1 by 2. What is tan 90 plus theta? Tan 90 plus theta is minus cot theta. So this gives me minus cot theta is equal to minus half, which gives me tan theta is equal to 2. Is it clear? Is everything clear to you till now? Okay. So we have the value of tan theta as 2. Now consider triangle APB. Consider the triangle APB. Angle A is 90 plus theta. Angle P is theta. Can you tell me the value of angle B? Yes, it is going to be 180 degree minus 90 plus theta, which will give me 90 plus 2 theta. So this particular angle is 90 degree plus 2 theta. When I'm writing 90, it means 90 degree. Okay. So that means angle PBA is 90 degree. No, it will be minus 2 theta, not plus 2 theta. It is going to be minus 2 theta. I'm writing it once again. So angle PBA is going to be 90 degree minus 2 theta. It's simple. You add 90 plus theta, what you will get? 90 plus 2 theta. You subtract it from 180, what you will get? 90 minus 2 theta. I'm just using the angle sum property in a triangle. Okay. So angle PBA is 90 minus 2 theta. I'm expanding the x-axis a bit more. Okay. Now, can you tell me what this angle is going to be? What the inclination angle of the image line going to be? So it is going to be 180 degree minus 90 minus 2 theta. What you will get? Yes, now you will get this angle as 90 degree plus 2 theta. Is it understood? That means the inclination of the image line is 90 plus 2 theta. So what is the slope of the image line going to be? It is going to be 90 tan of 90 degree plus 2 theta. So this will give me tan of 90 plus 2 theta. What it will become? It will become minus cot 2 theta. Yes, not theta. It will become minus cot 2 theta. This I can write it as minus 1 upon tan 2 theta. Further I can write it as, okay, I'm writing a little bit leftward. So further I can write it as minus 1 upon, the formula of tan 2 theta is 2 tan theta upon 1 minus tan square theta. We already know the value of tan theta, so I'm putting this value over here. Minus 1 into 1 minus tan square theta will become tan square theta minus 1. Tan theta is 2, so tan square theta, let me write it for you very first. So tan square theta minus 1 upon 2 tan theta. So it will become, tan square theta will become 4, 4 minus 1 will become 3 upon 2 tan theta. So 2 into 2 will become 4. So this is what the slope of the image line going to be. Now we have the slope of the image line. We have a point P also from where the image line is passing. So the equation of the image line is going to be y minus 5 by 2 upon x minus of minus 2, which will become x plus 2 is equal to 3 upon 4, which will further give me 4y minus 4 into 5 by 2. It will become 10 is equal to 3x plus 6. So finally I have 3x minus 4y plus 16 is equal to 0. This is what the equation of the image line is going to be. This is what the equation of the mirror image of the directrix is going to be with respect to the line mirror. I think each and everything is clearly understood to you. Yes. Now let us quickly go and have a look at the options. Yes, option C says 3x minus 4y plus 16 is equal to 0, which is absolutely correct.